Hi guys, welcome to Food Science Peeps channel. In this video, we are going to learn what is moisture content in food, why it is an important parameter in food industry, and also how to calculate it. Let's get started. What is moisture content? Moisture content is defined as quantity of water contained in a food material. Why moisture content is important parameter for food? Moisture content gives impact to properties of food such as texture, appearance, taste, weight and microbial activity in foods, which determines the quality and shelf life of food products. Optimal moisture content varies among different types of food. For example, fresh fruits like orange, strawberry and apple have high moisture content at about 90 to 95%. In contrast, spray dried milk powder has only 2 to 3% of moisture content. Excess moisture content in food will make food easily to be spoiled. For example, when fresh fruits and vegetables are kept in a moist container, spoilage bacteria can grow rapidly and turn the food to be inedible. Moreover, when biscuits are exposed to moisture, the moisture uptake may turn the biscuit soggy. As mentioned, moisture content can have dramatic effects on food quality and shelf life. This has been the reason why controlling the moisture content in food products has become a crucial part in food manufacturing industry. Moisture content can be expressed in two ways, which are wet basis and dry basis. Now, let's learn on how to calculate them. Wet basis moisture content is described as ratio of the weight of water to the total weight of material. In other words, wet basis moisture content is amount of water within per unit mass of moist food sample. Wet basis moisture content can be ranging from 0 to 100%, or 0 to 1. The term moisture content used in food industry usually refers to wet basis moisture content. It can be used as indicator for food products and food ingredients quality. For example, some flour mills limit the wet basis moisture content of flour to be not more than 14%, as greater value may affect the quality and shelf life of flour. On the other hand, dry basis moisture content refers to ratio of the weight of water to the weight of the dry matter. In other words, it is the amount of water within per unit mass of dry solids present in the food sample. Since the denominator is mass of dry solids, dry basis moisture content can range from 0 to very large percentage, which is maybe more than 100%. Dry basis moisture content is usually used to indicate moisture changes during drying. As weight of dry solids is constant, changes in dry basis moisture content is linearly related to the weight loss or weight gain when food sample is losing or uptaking moisture. The moisture content in dry basis and wet basis can be interconverted. Let's look at their relationship. Wet basis moisture content equals to mass of water divided by mass of moist sample. Mass of moist sample is the sum of mass of water and mass of dry solids. By dividing both numerator and denominator by mass of dry solids, we will get the equation which allows us to convert moisture content from dry basis into wet basis. On the other hand, dry basis moisture content equals to mass of water divided by mass of dry solids. While mass of dry solids equals to mass of moist sample minus mass of water. Substitute the mass of moist sample with sum of mass of water and dry solids. Then, divide both numerator and denominator by sum of mass of dry solids and water. Then, simplify the equation. We will get this equation that allows us to convert moisture content from wet basis into dry basis. In summary, the wet basis and dry basis moisture content can be interconverted by using these two equations. Let's look at some examples of conversion. Let's say the moisture content in wet basis given is 0.9 or 90%. To find out moisture content in dry basis, substitute 0.9 into the equation. 0.9 divided by 1 minus 0.9. We get 0.9 over 0.1, which is 9 or 900% of moisture content in dry basis. Let's say the moisture content in dry basis given is 1.25 or 125%. To convert it into wet basis, substitute 1.25 into the equation. 1.25 over 2.25, we get 0.555 or 55.5% of moisture content in wet basis. That's all for this video, thanks for watching.